All right. So basically, we're going to take a look at arrangements that have identical objects. So this latest project that we have here is we say we're going to determine how many unique arrangements there are using the letters A, B, E, E. So there are two letters that are identical. So you'll notice here that I have all of these arrangements. So I took the time and found all of the possible, let's call them arrangements of the letter A, B, E, E. So for this one right here, what I did was I fixed the A and then rearranged the B, E, E. So there was only three possible ways to do that. Okay. And then the same for these, for B. And then I fixed one of the E's and did fix the other E, and then started moving our E's together and various combinations until we got all unique possibilities of the letter A, B, E, E arranged. But you'll notice as you're doing this math, these arrangements, it's just very cumbersome. There's just too many possibilities here. And if I was a bad mathematician, I would have just said, well, list all the stuff and then get the stuff that isn't, that are the same, and take them out. So I could do that, but I'm a nice guy. I'm going to show you how to get rid of these duplicates when we do our calculations, i.e. the number of arrangements. Okay, so the first thing that you're going to notice is that if I look for the value, if I look for the list item, ABE, I've got 1 here. But then you'll notice a little bit farther down our list, we've also got ABEE happening again. So maybe we need to eliminate one of them. Now, that's what we would have normally done. We would have found all the duplicates and removed the duplicate one that we found. So for example, this one here, AEEB, I would cross out one of them that is duplicated, and I would do that for all of them, and that is just absolutely tedious. So if we go through all of these, we're going to notice that there will only be 12 remaining unique sets or unique letters that happen when we do the calculations. And when we say sets, we really are using the word combinations. So you'll also notice something peculiar. You'll notice that the list items that we have A, B, E, E, also has another one in our list, A, B, E, E. So imagine the first E gets put in, and then the second E gets put in as a third. Now that's how we could determine them. But you know what I would say? That because we cannot distinguish between the two E's, one of them is a clone of the other. So what we can do is to determine how to actually solve this to actually solve this kind of problem, the first problem, without doing any real work, is to simplify our problem into something a little nicer. Okay, so let's take a look at the problem where we have A with 3 B's. Okay, I'll show you what all the possible combinations are. So imagine we fix the A, then there's 3 B's after it. Then we also have a B with an A and two B's after it. And then we also have BB, AB, and then we have BBB and the letter A. So we know, based on this, that there are 4 unique combinations available to us. But how do we get that? Okay, so imagine, so this is how we actually imagine it, the calculation. So originally, we would have 4 objects. Okay, now those 4 objects, if we arrange them, we would have them labeled like this. And in the first spot, there would be 4 opportunities to choose. Then we're only left with 3, then 2, and then 1. And this is the rule of products again. So we would multiply all of these together. Now, the only issue is what would happen when we have 3 identical letters. So what we have to do is we start with our 4 objects, and 2, we look at the cloned letters. Okay, so those cloned letters there's 3 of them. There's B's, right? So the B letters are 3, 2, 1. You choose 3 of them, you get 1, you choose another one, you get 1, you get another one. So what we do is we basically figure out the arrangement of the cloned letters, and that's going to equal 6. This first one was equal to 24. Okay? So essentially what we're going to do in order to get our final answer, we basically do this. This is what I call my recipe. We take the total arrangements and then we divide out the arrangements of the clones. So let's go and take a look at at how we would do this. So mathematically speaking, stage 1 for our problem would be 4 factorial divided by, well, how many things that are the same in that thing? You've got 3 B's, so we're actually dividing out. So these are the matching B's. And all we're doing is we're dividing those out, and that gives us 4 factorial divided by 3 factorial gives us 4 arrangements, which is what we're looking for. And that is the concept that we're working with today. So let's talk about the equations for permutations of clones. The first thing we do is we figure out the total number of ways something is arranged. Then we divide out all of the matching or repeated letters. Okay? And we can do that ad infinitum forever. All right, so let's take a look at the example for Mississippi. All right. So for Mississippi, N is equal to 11. 11 letters, okay? So the I's, let's take a look at the letter I's. So I'm just putting i's. How many i's are there? There are approximately 4 i's. Then we have how many s's? We have 4 s's. Okay. So we have n i's, 4 s's, and there are 2 p's. So here's how we calculate the number of ways, or the number of arrangements. So the number of arrangements is going to be, well, you take the n value, which is 11 factorial, then you divide out all the i's, the arrangements of the i's. So basically we have this represents the i's, and then this one here, this other one, 4, this other 4 factorial divides out all the arrangements of all the s's. And then the 2 factorial divides out all of the p's. And we're done. Now, all you have to do is punch that into your calculator, and you get the final answer of 3,460 ways. Mississippi can be rearranged. And we're done. All right, let's take a look at the last problem of the lesson for today. I want you to determine how many ways the letters in Mitchell can be arranged. First of all, pause the video and then see if you can come up with a solution and try to use what we know from before. Okay? Then unpause the video and see if you get the right answer. So the number of letters is 8. L is 2. And there should be no more letters that are the same. So you're going to get the following. Well, here are the arrangements. The number of arrangements is equal to 8 factorial divided by 2 factorial, and indicate what you're dividing out. In this case, we are dividing out the L's. Okay, so we get our final answer of 20,160. Therefore, there are 20,160 ways to arrange Mitchell. And we're done. Your homework is page 245, questions number 1 to 13. So your homework is page 245, questions number 1 to 13. You can find that as lesson number 3 on your course material.